Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. This is section 3.2, and we're going to look at subsection 3.2.1. What is this about? Counting polynomials. Notice it says counting, and we have polynomials. And now we have this thing with committees. What's going on? Well, we're going to use polynomials to help us to count certain things. And what we're counting, at least in this example, is we're going to count how many ways there are of forming a new committee, D, from these committees based upon certain criteria. And we're gonna put that criteria per each one of these committees. So this is kind of what we're doing. So we're going to count the number of ways of doing something, and polynomials are going to be our friends. They're going to help us out here. So in particular, what we want to do is we want to form a committee of 4 people. That the people come from these committees, but we also want to restrict something. We're going to say that Julie and Eric, if they are on the committee, they have to come together. Also, if Andy, Allison, or Amy are on the committee, they must also come together. So let's see how we might want to do this. Let's tabulate the information. You see the word length and the number of ways. You could think of this as frequency. So frequency and length. What does length mean? That means the number of people that we can pull from committee A. How many, and this is the number of ways that we can pull this number of people from committee A. So there's one way of pulling no one. Just if we're just looking at committee A, just at committee A, there's only one way of pulling no one from committee A. That's just to do nothing from committee A. Okay. From what about how many different ways there are of pulling one person? There's 2, either Susie or Harriet, because Julian and Eric have to come together. So right here we have there are 2 ways of pulling 2 people, because we can do Julie and Eric as a chunk or Susie and Harriet as a chunk. There are 2 ways of choosing 3 people, right here or here, because Julie and Eric have to come together. And 4, there's just one way, everyone. And we similarly do that for each one of these committees. Now, why is this tabulation helpful? Well, let's think about these green numbers as exponents, these blue numbers right here as coefficients. So there's actually a committee that is describable, or there's a polynomial that we can describe using this data. And then after we see how those polynomials are formed, we'll discuss how they can actually be helpful in determining the number of ways to form committee D. So let's take a look at this. Let's come down here and look. This is the polynomial that corresponds to committee A. Notice its coefficients 1, 2, 2, 2, 1, as our exponents go from 0, 1, 2, 3, 4. Let's see. Coefficients 1, 2, 2, 1. So 1, 2, 2, 2, 1, as the exponents go from x to 0, x to 1, x squared, x cubed, x to the 4th. And then those are the coefficients. These are the coefficients, and those are the exponents on the powers of x. So we can, from this data, we can get a polynomial for committee A. And then from this data, we can get a polynomial for committee B. From this data, we can get a polynomial for committee C. So we have our different polynomials listed out right here. Now notice on this line, we're multiplying them together. Why would we be multiplying them together? Well, kind of what we want to do is we want to think about ways of, so how can we form a committee of 4 people? Well, if we form a committee of 4 people, then we have to maybe pull, if we pull 2 people from here, then we could pull 1 person from here and 1 person from here. That's one way of doing it. Or we could pull 3 and 1 and 0, or we could go 1, 2, and 2, or or we could go 4 and 0, or any number of things like that. So those are the different things we can do to form our committee D. And then also here, if we're doing that, like for instance, if we say 2 from here, 1 from here, and 1 from here, then the number of ways of doing that thing, so 2, 1, 1, we can multiply here. So 2 times 3 times 1, so a total of 6 ways of just pulling the 2, 1, and 1 in that particular manner. So we're pairing things together. So we're taking different so the length is referring to the number of people we can pull. So we're taking a different line here and we're combining it with a line here and then a line here. So we're pairing those, but we're trying to match 4 when we add these things together. So wait a minute. So we're adding lengths. Adding lengths is the same thing as multiplying powers of x, where these are exponents, because exponents add when you multiply. That's a good thing to realize. But we're trying to take a power of x here, a power of x here, and a power of x here, and multiply them together so that we get x to the fourth. So we're pairing all the options to give us x to the fourth. Well, pairing options together, or kind of putting options with each other, is actually accomplished with the distributive property of multiplication. If you so if we were to multiply all this out, we would be distributing things in every possible way, like one thing from here, one thing from here, one thing from here. And then if combining like terms, if we combined all the x to the fourth terms, that's like adding together all of the all of the various number of ways there are of how you could get it to x to the fourth. And as we add those like terms up, and the resulting coefficient will actually be the total number of ways of forming a committee D. So we simply just need to multiply these polynomials together and look at the coefficient of x to the fourth, and that'll be the result. Now, how to do this by hand? Let's talk about some things that'll help. Well, for one thing, if we're looking at the coefficient of x to the fourth, x to the fifth won't matter to us. So it'd be helpful to maybe look at a quotient like this, or a merge like this, where x to the fifth will be the same as 0. That means all the powers of x, 5 and above, can be ignored in our computation, and we'll be just fine. So we're going to be working mod x to the fifth here if we're looking for, if our target is x to the fourth. So now let's talk about a procedure we can use to make this even faster. Notice how I'm writing out the coefficients of this polynomial, the coefficients of this polynomial, and the coefficients of this polynomial. Okay, and then let's think about just multiplying these guys, okay, the first two polynomials together. What's going to happen? Well, I have a little tabulation here, and let's talk about how this would work. This is a tabulation for multiplying this guy times this guy, all right? So this is like a 1 plus 3x, so you can even look 1 plus 3x. So the powers of x actually increase going this way in the way I've written this out. So 1 plus 3x squared plus x cubed. Okay, so as we look at this 1, 2, 2, 2, 1, and so that's like this whole thing, and we're multiplying it by 1. This one right here can be thought of as in red, this red one. In fact, if you look at this 1, 3, 3, 1, notice 1, 3, 3, 1 going down this way, and then going this way we have 1, 2, 2, 2, 1. So we distribute this one to this whole thing, and that's what we get on this first line. Now next, this is a 3x, right? That's a 3x. So when we multiply by x, x to the first, what does it do to all the exponents? You're adding 1 to all these exponents, so you're shifting this up. So you take 1, 2, 2, 2, 1, and you shift it over. Oh, but you shift it into a power of x to the 5th, and so you can ignore it. So it swallows it. It goes. It's out. It's out of there. So if we multiply by 3x, we can shift everything over and just distribute the 3 times this whole guy, but just shift it over. Similarly, this is 3x squared, so it'll shift everything over 2. So it shifts over just 1 more here, so 1, 2, 2. But then we're multiplying, we're distributing the 3 through, that coefficient, 3, 3, 3. And then similarly here, this is x to the 4th, so when we multiply it here, it'll, let's see, or x cubed, I guess. Sorry, this is x cubed. Yeah, let's see it. It's x cubed right there. So when you have x cubed and you multiply it through to all of these, it's going to shift everything up 3. So just shift 1 more over from the last line. And so it's a 1 here and times all of this, but we've shifted it over and we can ignore that. So this is what the polynomial will look like now, but we're ignoring everything beyond x to the 4th. What we do is we simply just add up these are the coefficients of x to the 4th. We just add those, add these, add these, add these, add that. So we end up getting the coefficients of our polynomial after multiplying at least up to x to the 4th. So we've just added, or we just multiplied the first 2 polynomials, and it doesn't take very much just to quickly do this, write this out, shift, 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 and then just multiply all this by 1, 3, 3, 1, and then add across, we're done. So not too much work. We can multiply a 4th degree polynomial by a 3rd degree polynomial and just concentrate on what's important. Okay, next, we take this result and we need to multiply it to that polynomial. Okay, so we have something very similar. So we have this guy, 1, 5, 11, 15, 15, and we just kind of do a triangle, shifting it over. And then we put these down, 1, 1, 0, 1, 1, just like we saw right here. And we multiply through and add, and we get our different coefficients. Now we don't have to add these. That was unnecessary at this step because this is the last polynomial to add. If we're just looking for x to the 4th coefficient, it's right here, just here. We just have to add this one line, be done. So we notice 36, which means there's 36 different ways of forming that committee D. So now we could use these numbers as well. What do these numbers mean? So this number right here means that there's one way of forming a committee of size 0, because x is to 0. This means there are 6 ways of forming a committee of size 1, 16 ways of forming a committee of size 2, 27 ways of forming a committee of size 3, and 36 ways of forming a committee of size 4. Okay, so that concludes our first example of polynomial committee and quick tabular polynomial multiplication, and how we can use polynomials to help us to solve a counting problem. In the next video, we will look at another example. We're still in the same subsection, but this next example will be on counting something called an additive partition. Thanks for watching.